Check, check. All right. So I want to continue the theme for this afternoon, which is baldness. I don't know who else is up after, but take a hint. Thank you for coming. Thank you for listening. Openstack is one of those things that everybody uses, but just as many people like to trash talk it. So it's interesting to see this many people here listening about Openstack. I'm Pete Lumbus. I'm a technical marketing engineer at Cumulus. I've been in the industry for a while, CCAE, CCDE. We're not here to talk about Cumulus, but talk about a quick overview of Openstack with regards to networking, and then just talk about some network design options when it comes to deploying Openstack, and some pros and cons. I'll finish with some recommendations, but the classic network design answer is it depends. So listen to me, don't listen to me. I'm not your boss. So as an overview of Openstack and what it is and what it provides, is it takes a pool of servers, right? This racks and racks of compute, and it's going to deploy VMs on those servers. That's going to be disk size, how much memory, how much CPU, how many cores, whatever. It's going to attach those VMs to networks, L2 segments. It's going to provide the resource management across the infrastructure. How many VMs can fit on a server? What are my resource policies? What are my security policies and things like that? And it's a microservice style architecture. So each thing within Openstack is a standalone component. And this is really why everybody thinks that Openstack is so complex. And I'm definitely not saying it's not, because it is super complex. But it's because it's not a unified system. Everything has APIs that every component talks to. So for example, if I'm in the GUI and I want to see a list of networks, the GUI component is actually going to make an API call to the network component, pull back that list, and then present it. If I want to see the list of VMs, it actually has to make a call to a different application called Nova, the compute manager, and get a list of VMs that are running on a given server. So that loose coupling allows Openstack to be super powerful and super flexible, but as everything in engineering, there's a trade-off, which in this case is complexity. So we're going to talk just about Nova, which is the compute services, and Neutron, which are the network services. So these are just the project names that Openstack has given them. So Nova is the thing responsible for deploying a VM. Again, it's going to manage that VM's capabilities, its disk size, its memory, its CPU. The Nova nodes are the bare metal servers on which I want to run VMs. So if I have a rack of compute and I'm going to deploy VMs on that rack of compute, those are all Nova nodes. On the other side, we have the network services, which Openstack calls Neutron. Neutron manages the list of tenant networks. And to speak here, the language of tenant means a VLAN or a VXLAN, an L2 domain. It's going to assign a tenant network to a VM. Or I should say a VM to a tenant network. The network stack on the Nova nodes is programmed by Neutron. So just like I said, we have these loosely coupled components. So I have my Neutron server, my Neutron node with a VM on it, and I need to plumb a VLAN to it. So Neutron, the network component, will speak to Nova, the compute component, via APIs and build that programming. And we'll show you a little bit more of this in just a second. Optionally, I can have an ML2 driver, or the modular layer 2 plugin driver. And this allows a Neutron server to talk to a physical switch and provision VLANs or VXLANs through a common API. This ML2 driver is provided by the vendor. This is not an Openstack thing. So Cisco builds an ML2 driver, Arista builds one, Cumulus builds one. Everybody builds their own driver to talk to their own network devices. And the focus of Neutron is really layer 2. It's about VLANs and VXLANs and those tenant networks. Layer 3 is generally done on a cluster of compute nodes. And the main reason it's done there is that we're looking at a bunch of additional services. So things like firewalling, NAT. It's usually a lot more than just an L3 gateway, because I have a whole bunch of tenants all getting address space in, say, the 10.x network. Well, if they're going to go out of that Openstack cluster, I'm probably going to need to be able to provide NAT services and to be able to dynamically build NAT pools for tenants as they come up and come down isn't something that most firewall or load balancing hardware is very good at today. We can also do things like distributed vRouters for L3 through Openstack, where every VM's local gateway can actually be the x86 node that it lives on that local compute node. So I can either go all the way to the edge of the network to an x86 cluster of L3, or I can put that L3 gateway within the compute server itself. So let's kind of break down some of these things visually. So I have racks and racks of compute. These are my Nova nodes. These are where VMs run in the infrastructure. They're going to connect into my network infrastructure and my top of rack switches. Somewhere, I assign a couple of servers to be my neutron nodes. These are my L3 gateways, my NAT devices, my programmer of networks. These neutron nodes are actually going to be the ones that program the VLANs and VXLANs in the environment. And then I have some other x86 nodes that are the Openstack controller nodes. They're the global manager that kind of owns everything and makes all the calls and provides all of the orchestration. So as we look at how a VM is deployed, a user is going to request a VM. They're going to supply their parameters, like the amount of RAM, the disk, all of those things that you would normally do to deploy a VM. That call is going to go to that global controller node. It's going to receive that and process the request. Based on whatever magic, small elves, I'm not really sure how this works, it will find a server within the compute cluster to deploy that VM on. At the same time, the Openstack controller will make an API call to Neutron and say, hey, I just deployed this new VM. It's within the blue tenant. Can you please connect it to the blue tenant network? That Neutron controller will say, have I ever built a network for the blue tenant before? Do I need to build a DHCP pool? Do I need to build an L3 gateway? What else do I need in this environment to support this device? If I have already built it, then I'll just provision the VLAN. If I haven't, I'll do a bunch of extra services as well. After making that decision, the Neutron node will program that VLAN directly on the compute node, and now I have an L2 segment. A lot of work just to spin up a VLAN or a VM. If I've deployed ML2 because I want to do something with my top of rack switches as well, the Neutron node will also, either alternatively at the same time, again, we'll go into some of these options in a minute, it will speak through ML2 directly to that physical switch, whether that's top of rack, end of row, leaf spine, whatever you want to call it, and provision those VLANs or VXLANs there. ML2 will then translate that API call into device-specific configuration. Because Openstack doesn't speak iOS, Openstack doesn't speak Junos, Openstack speaks Openstack. ML2 is the translator from Openstack to device config. So we're going to talk about some network design options, but before I go into that, can I go back? Yeah, any questions so far about the Openstack components before we start diving into the design? All right. Of course, you can always ask questions at the end. So the first option is a VLAN-based networking option. And this is, hopefully everybody in the room is aware of building VLANs to build networks and tenants. If you're not, that's OK. It's a safe place. But it's going to be the most common option. And I think the reason it's the most common option is because server people don't understand networking. And so they're like, yeah, VLAN, like the numbers are different, so it's a different tenant, like it's fine. So we see a lot of VLANs because OpenStack has grown very organically in a lot of organizations. So it starts as a couple of compute nodes, and then it turns into a rack, and then it turns into 4 or 5 racks, and all of a sudden you have this CIO level initiative of OpenStack with this just tire fire of a network behind it that you're now in charge of. So that's awesome. The next option, kind of a much more forward-thinking approach, is using EVPN and VXLAN. So it's still a very network-centric design. We're really putting a lot of onus and effort on the network itself, just like in a VLAN-based design. But we get a lot of the advantages of VXLAN, of being able to build an L3 core, being able to distribute a lot more information, building a more scalable environment. But there's another option that doesn't get talked about a lot, and that's VXLAN on servers. This is really the most scalable and most cloudy way to do things. It creates the simplest network where I only run a layer 3 network everywhere, including down to the server. So nowhere in my environment do I provision VLANs or any L2 broadcast domains at all. And I rely on the server and the compute nodes to own their own fate from an overlay and tenant network. So I, as a network administrator, end up acting like a service provider where I push the edge all the way down to the compute node. And then I just provide an SLA and an infrastructure. And how that compute provider manages, operates, and interacts with that infrastructure is completely up to them. However, we're now pushing that complexity somewhere else. Complexity doesn't evaporate. It only moves around. I think of it a lot of times like an air bubble in a sack of water. I can't take the bubble out. I can only move it around. And so in this case, we're taking the complexity from inside the network in that VLAN and pushing it into the compute node on the server side. And you have to make a decision, is that complexity worth the trade-off? So if we look at the simple model, we'll walk through each of these models and some of the options you can do for each of them. If we look at the simplest model with just VLANs, what you can do is just pre-provision the VLANs everywhere. So I put network trunks carrying all VLANs on all ports. So across my network devices, I take all of my VLANs, I allow them over the trunks, I put them down towards the servers. The servers may trunk all of the VLANs, but they're not required to. And so this is what my baseline looks like before any VMs exist. I have a physical bare metal server with a trunk allowing all VLANs north up to the switch. I have a switch with trunks allowing all VLANs down to the servers, and trunks allowing all VLANs on the inner switch links. When a server creates a VM, the only thing that changes is attaching that VM to the network. So I spin up a VM, a new tenant, in one of these VLANs. The neutron node will poke the compute nodes where that VM stood up and attach it to the VLAN that was already provisioned. So we have from the OS down to the NIC, the VLAN was already there. And what Neutron's doing is it's going from the VM or the vSwitch down to the hypervisor. This is the Ron Popeil method. You set it and you forget it. So I build the infrastructure, I deploy all the VLANs, and I walk away until it all melts down because everything's terrible. The other option here, well, we should look at the pros and cons of this design. So it is the easiest model, right? Again, I said it and I forget it. I mean, server people figure this out. No offense, server people. A little bit of offense. The physical network stays very static. I don't have to interact with it. I don't have to do change requests. Everything is there. It lives there. It stays there. And I don't have ML2. I don't have to have Openstack poking my switches. The downside, it's extremely limited in scale. Sure, we have 4096 VLANs. Sure, that's more than enough tenants than most people need. But the reality is almost no switch on the market can actually do 4096 VLANs across all ports. There's almost always other limitations. Or if they can do 4096 VLANs across all ports, reload that switch and tell me how long it takes to boot. I have an extremely large blast radius. The first time that somebody accidentally bridges instead of bonds on those VMs, like, goodbye Friday night. So a variation on this theme is using ML2. So instead, I don't pre-configure anything. I reduce my blast radius this way. I have trunks configured, not passing any VLANs at all. So I've built the roads, I'm just not allowing any traffic on them. I'll use the ML2 agent on every device in the network. Neutron will come along, and as it provisions the VMs, as it extends the network out of the VM, out of the host, it will also poke the ML2 agent and provision those VLANs on all of the switch links in the infrastructure. So again, super simple server networking. I don't have to pre-provision. I don't have to give my network team a list of things that they need to know about. They just listen to the Openstack API calls, and Openstack does the magic. Again, I hope this is a level of networking that our server folks can handle. I'm getting a lot of hate on the server folks. I love server folks. It is slightly more scalable because I'm not putting all my VLANs everywhere. I do get the possibility of putting some VLANs in one rack and some VLANs in another rack, and therefore getting greater scale. I'm a little bit more of a pragmatist, and I believe that that's not ever going to actually happen, and everything's going to end up looking very uniform, and you're not actually going to get scale benefits. Again, cons. Now I have to have ML2 on switches. I have to have this agent thingy dynamically configuring and changing my switch, and we all know how we feel about things dynamically changing our network out of our control. I'm still limited by that L2 scale, both from a blast radius and from a 4096 VLAN scaling provision. And again, I'm very likely to eventually have my weekend ruined by some massive outage. I like my weekends. So I've thrown some shade on ML2 agents on switches. So let me give you a little background on ML2 agents. Openstack itself is designed to be cloudy. It's a cloud. Everything in a cloud is ephemeral. It can die at any time and nobody should care. VMs can die, disks can go offline, the network can change. Nobody should actually care about this. And this includes networking. The network should be allowed to die at any time in any component. I should be building high availability into my application and building better apps instead of lighting money on fire to provide more redundancy and resiliency in the infrastructure. However, we all live on planet Earth, and nobody actually accepts this fact. With ML2, there might not be any configuration behind it, meaning that if a VLAN is pushed from ML2 down to that device, it's up to that vendor to determine whether or not that VLAN exists in the configuration or only in the state of the switch. So if I reload the switch, it's possible that I lose all the state that was provisioned by ML2. It very much depends on the vendor implementation. For example, at Cumulus, we push configuration into the box, so after reload, we keep it. Arista, if you have Cloud Vision, you can replay state from the Cloud Vision controller, but without Cloud Vision, you would lose everything. I don't know what Cisco does. I tried to figure this out and got distracted. And so what this can mean, though, is that the loss of state, the crash of a switch, the loss of power or reload, means that every single VM in that rack would have to be re-provisioned to be able to get its network connectivity back, because it's ephemeral. OpenStack's not keeping these lists. It doesn't know what these things are. It can't scale that way. It made an API call and expected that API call to be fulfilled. If the switch reloads and it loses that state, I can't just go and ask OpenStack for that state again. OpenStack doesn't have it. So I have the Oprah face when I hear that. I feel like that. So if you're using ML2, I'm not saying it's bad. I'm saying make sure you understand the vendor implementation and any possible restrictions there. So let's look at other options. The next one here is using VXLAN with EVPN. For those unaware, VXLAN is going to provide layer 2 connectivity to an L2 tunnel over a layer 3 network. It's very similar to something like VPLS, but significantly less terrible than VPLS. And if you don't think VPLS is terrible, then you clearly don't use VPLS. Yeah, see, some of you use VPLS. You know what I'm talking about. EVPN is going to provide the control plane. It's going to advertise which MAC addresses live behind which devices. So as a VM spins up and a MAC gets learned on that switch, it'll use BGP EVPN to tell the rest of the network, hey, this Mac lives over here behind me. If you want to talk to it, let me know. EVPN is configured from Tor to Tor, from leaf to leaf, from top of rack to top of rack. Generally, there's a lot of design options here, and that's not what we're here to talk about today, but generally you're not going to run EVPN on your spines or in your core. It's only on the top of rack switches, only at the edge. Again, just like MPLS, you can think of it exactly the same way. You're doing peering from PE edge to PE edge, not within the Ps, not in the core. So I build this EVPN peering across the data center, and I can pre-provision VXLAN tunnels. So this looks a little bit like the previous scenario. Right? I'm still going to end up limiting myself by the number of VLANs. But I can pre-provision all of the VLANs or the VXLAN tunnels that I might ever see. So if I say allow 1,000 tenants, I can pre-provision 1,000 VXLAN tunnels and just wait for that traffic to show up. And I get scale improvements here because if I don't have a tenant attached locally, then I just leave the routing information in software. I never push it down into hardware. So I lower the risk of blowing up my entire data center. When there's a problem, I only blow up a little chunk. And just to be clear, Openstack does not care at all about EVPN. There's a lot of things Openstack doesn't care about, including your feelings, but in this specific instance, it doesn't care about EVPN. And so EVPN is just acting as a transport for Openstack to do things on top of. It doesn't speak EVPN, it doesn't interact with EVPN, it has nothing to do with BGP. So again, what does that look like on a step-by-step provisioning? I launch a VM. That VLAN gets provisioned on the host. The Neutron node provisions the ML2 agent on those switches. Those provision the VLANs down on the local trunk links to the servers. So at this point, all we've described is VLAN-based provisioning. The switch itself, its configuration that would have been pre-provisioned, would map that VLAN to the VXLAN tunnel that was pre-provisioned. Let's skip ahead. So I would rely on that VXLAN tunnel over the top that was already there, already in place, that once the VLAN showed up locally, all of a sudden becomes an avenue that I take and I program routing and MAC address information for it. So ML2 is only provisioning VLANs as it did in the previous examples, but instead of running layer 2 trunks across the network, I'm relying on VXLAN tunnels to provide that. Alternatively, I could pre-deploy all those VLANs as well, so I get some scalability from having VXLAN over the top. So instead of just pre-provisioning VXLAN tunnels, I could pre-provision VXLAN and VLANs and let the servers dynamically attach as necessary. And so in this case, what's nice about this is that Neutron is only touching the servers. I'm no longer relying on ML2. So again, as Neutron comes in, provisions that network segment, it attaches, and now I'm attached to that segment. So the pros is that it allows for an all L3 underlay. Hopefully, again, we all know that just as layer 2 is bad, layer 3 is good. So we want to build that layer 3 network in the core for greater scalability, greater stability, and then have to do the dirty, terrible layer 2 over the top. We hide our shame in a VXLAN tunnel. It'll easily scale, in the thousands of tenants. The numbers all depend on chips and vendors and software and things like that, but I would feel very comfortable telling any customer, look, if you're looking at 100 to 1,000 tenants, this will probably be fine for you. You're not going to make me feel uncomfortable. Pre-provisioning, again, is very easy, both from a VLAN and a VXLAN capability. I mean, hopefully you're running some sort of automation, but it's really just a copy and paste job across the board. The downsides, again, it may still require ML2 on switches. We've already talked about my feelings on ML2. The network is still involved. So I still have a lot of dynamic things happening within the network. And so I'm trying to provide a high uptime infrastructure and a very dynamic, highly ephemeral system. So it's not without risk. I mean, and this is another one of those, like, if you haven't had changes that go sideways, you haven't been operating very long. And so what we're talking about with a lot of these is making dozens of changes a day. That makes me a little uncomfortable. So we can do better. We can build a network architecture that gets away from ML2, that gets away from that blast radius, and really gives us the stability and scalability that we need when we're building clouds. And so what we look at is server-based VXLAN. So my host is going to connect to my top-of-rack switch on a routed port. Not an access port, not a trunk port, not a layer 2 interface, but a routed layer 3 interface. My servers can run any sort of routing software, like free-range routing, the open source routing suite. It's a fork of Quagga. They talked about it in the earlier session today. And my server will run eBGP to the top-of-rack switch, building a complete eBGP fabric from end to end. No VLANs, no layer 2. And if I want to dual attach, I never have to ever see another type 1 VPC inconsistency ever again in my life. Because, again, I used to have hair, and then I worked in tech. And so I can dual attach and do ECMP routing, or if for some crazy reason I want more than 2 top-of-rack switches, I could triple or 4x attach and really spread out that load across the switches, because I'm not limited by MLAG or VPC anymore. I'm only limited by routing. And then my server is going to have a /32 loopback IP, and I'm going to advertise that into the network. So every server gets one IP, I advertise that IP into the network. If I'm worried about scale and sprawl of these, the first thing I would say is your network's probably not that big, because most of the data center switches support something like 32 to 128,000 /32 routes. And so if you have 128,000 servers in a single data center, you've already solved this problem. But if you still insist on feeling nervous about this, you can still summarize, say, at the top of rack and advertise a /24 representing that rack, and then have every server have its own /32 loopback IP within the rack. And again, Openstack has no relationship with BGP. It's not speaking BGP. It's not programming BGP. Again, we're using BGP as a mechanism to build this underlay fabric for Openstack to do things on top of. So what happens in this scenario is, again, I provision a VM. I allocate the local segment for that VM within the hypervisor. And Neutron also understands VXLAN. And so the Neutron node will not only provision that VLAN from the VM, but it'll provision a VXLAN tunnel for it that goes from server to server. The server loopback interface, that /32 that we just talked about, is the VTEP, or the VXLAN tunnel endpoint. That's the endpoints of the VXLAN tunnel. If I did a packet capture on the wire, my source and destination IP addresses for that VXLAN packet would be left server loopback to right server loopback. The only thing that comes out of that host is VXLAN encapsulated traffic. We never have layer 2 traffic. We never have broadcast traffic. We never see anything in our physical network except for this VXLAN encapsulated traffic. This is exactly what I mean by saying you can now act as a service provider within your data center. Because, look, whatever you're doing, your rule is it has to be routed. If you need layer 2, if you need an additional service, if you need multicast, you got to figure out some other way to manage it. It's not my problem. The switches are only providing that layer 3 routing. And it's up to Openstack to link the VM, the VLAN, and the VXLAN. The VM itself is not aware of any of these things. It's no different to the VM. It's no different to that tenant. It still has a normal Ethernet interface into a vSwitch. What's happening is that the vSwitch is plugging in a VLAN on one side to a VXLAN on the other side. And that magic plugging in a VLAN to VXLAN is exactly what Neutron manages. So again, I, as a network operator, as a network engineer, care so little about your Openstack install that it's not even funny, because it's not my problem anymore. All of that gets handled in the compute layer. Pros, it's super operationally easy. I never have to look at MLAG or VPC ever again. I get super highly redundant, highly scalable network design. If I'm using free-range routing, I can actually use something called BGP unnumbered, so I can plug and play my servers. They all peer over IPv6 link locals and exchange v4 and v6 routes. So I don't have to assign an IP to every single interface on every single link, because that is awful. And so I can actually just plug a server in, and it'll automatically become peers. I don't have to do a bunch of IPAM. I can do zero packet loss upgrades and changes. So now the way that we do dual attached MLAG VPC upgrades and changes is we go into the data center, we make sure nobody's looking, and then we turn it off and hope that the server bond failed over properly. And if it didn't, we quickly turn it back on and hopefully everything's OK. But now, because it's fully routed, I can do something like change an OSPF cost or send a higher AS path down to the server, have the server update its routing, and automatically switch over and only use one of those two paths. It's extremely scalable. I don't know if you've heard of the internet, but it also uses BGP. It seems some of you may have. The downsides. This isn't perfect. If you don't have VXLAN capable NICs, you will take a performance hit. So VXLAN in network cards is kind of where TCP was like 10 or 15 years ago. Every single network card that costs 99 cents from Fry's does TCP offload now. Most of the network cards that you buy, or like a LAN on motherboard, might not provide VXLAN offload capabilities. So that means the VXLAN in-cap and decap is happening on the CPU. It's within the kernel, so it's still pretty fast, but there's going to be a CPU overhead to it. So if you're looking at this model, you want to make sure that you're also looking at NICs that can do the VXLAN in-cap and decap within the hardware itself. It requires FRR in servers, which pretty much makes everybody uncomfortable. Network people don't like the idea of running BGP to a server and letting those unwashed heathens of systems administrators speak the holy word of BGP to my network. And then systems administrators are also looking at BGP and they're like, yeah, that's what the network folks do. They live in the basement. I'm DevOps. I'm cool. We have hoodies. And Openstack has something called ironic. Although Alanis Morissette has nothing to do with Openstack, ironic is the project for bare metal servers. So all of this has been about VMs. Openstack has a project called Ironic that allows you to provision bare metal servers for a tenant. So this model is great when I still own the NIC. And if I own the NIC, I have a layer of indirection, or I can make enforcement and policy judgment. But if I'm giving you a full bare metal server, and I don't own the NIC, I don't own the operating system, my point of enforcement becomes a top-of-rack switch. And so in that case, I would still need an ML2 plugin to support a bare metal server. The one thing that's nice here is that it does seamlessly integrate, in which I could do VXLAN from a compute node to VXLAN to a top-of-rack switch without a problem. So what should you do? The first question you should ask is, how many tenants do you have? This is probably going to be the biggest single deciding factor on how you should deploy or what technologies to leverage. I am one of the biggest layer 3 zealots you will ever meet on the planet, and I'm standing in front of a slide that says layer 2, where none of us are perfect, including me. So if you have less than 50 tenants, the reality is just deploy layer 2 everywhere. Like, it's the complexities of all the layer 3 stuff. I love it. I'm a huge proponent of it, but it's also kind of a pain in the ass. So just deploy layer 2 everywhere, pre-provision it all, call it a day. If you're in the 50 to 1,000 tenants, seriously look at VXLAN with EVPN. Whether or not you're pre-provisioning or not, think about it. There's some trade-offs. I think it has more to do with how comfortable you feel doing that rather than an actual technical decision. And if you're greater than 1,000 tenants, I mean, you're a cloud. You're a true cloud provider now, and you have to build a network like a cloud provider. You can't build a sad sad layer 2 network as a cloud. And I say that having spoken to many cloud providers of layer 2 networks. I won't name names. You know who you are. But look at building a true layer 3 network. Route down to the server. Get rid of layer 2. Eliminate those broadcast domains. Eliminate that blast radius. The next one is, how uncomfortable am I by having Openstack talk to my network? So take a survey on a scale of 1 to 10. If you're OK with Openstack programming your switch, then do something that can require ML2. ML2 solves a bunch of problems. It's a valuable tool in the toolbox. But you have to think about what is the trade-off, and am I OK with that trade-off? And if not, then either you have to pre-provision or look at server-based VXLAN. And then finally, VLANs versus VXLANs. Always, always, always prefer VXLANs. That ability to do L2 over an L3 core is extremely powerful. It's going to allow you to scale out and build out that network with a lot less heartburn. But just be aware that your hardware needs to support VXLAN. That means both the server NIC as well as the top-of-rack switch. Most data center switches you can buy today have VXLAN support within the hardware, so they can do VXLAN at line rate at 10, 2500 gig. But you got to make sure. If you're taking an old campus switch out of the trash, put it into the top of rack because you're starting your OpenStack project, guess what? That 2960 isn't going to do VXLAN. But again, anything modern, especially anything probably in the 25 gig range, you're not going to have a problem. But it's a question you need to make sure that you're asking. And so as I mentioned, server NICs as well. And so one final note is this has really been all about layer 3. Or I'm sorry, all about layer 2. So what about layer 3? Layer 3 is a different plugin within OpenStack. You might be surprised to know that it's called the ML, anybody? 3 plugin, right? ML3, because they're clever. There's not a lot of vendor support out there for ML3 plugins. Arista has a plugin, Cumulus doesn't. I'm, again, not sure if Cisco does. But the big thing is that it almost always requires NAT. And I mentioned this in the beginning, in which the hardware, that network hardware that might be programmable, does it also support NAT? And if it does, what are the trade-offs of it? What can't it do? And so what ends up happening is, again, that ML3 component tends to live inside of an x86 node and letting software do it, because I can do anything in software at the trade-off of speed. And then the other thing is, this is where a lot of conversations around service chaining and service meshes start to come into play, because look, the reality is I don't just want a tenant that gets to the internet. I want that tenant to be behind a firewall. I want it to have load balancing services, and I want it to have certain specific access rules so that I can come in from the internet, hit a caching tier, go through a firewall, hit a web tier, so on. So there ends up being a lot of other additional as-a-service components that are required within the infrastructure. And this is another reason why you don't see a lot of ML3 plugins on hardware, because, again, that service chaining ends up being significantly easier when I'm looking at servers to do that kind of work. That's all I have. So any questions? Thank you.
Hi, Lee Howard from Ritevia. You know, I guess I ask the same question of everybody all the time, so everybody who knows me knows what I'm going to ask. Everything that I heard you saying here, the trade-offs you have to make, it sounded to me like you were saying, if only I could use IPv6. And doesn't IPv6 solve all of your problems?
IPv6, you know, that's a really good point. IPv6 only solves the NAT problem, though. It doesn't solve any of the other problems. Because the thing with multi-tenancy is, it's not an addressing problem, it's an isolation problem.
Well, okay, fair. Yeah, you don't need to build overlays. You still need ways to control your policy, your host-to-host policies, which could be local firewall rules or ACLs anywhere. Yeah, and so you know, the host-based firewalling, the host-based ACLs, I think is extremely amazing and awesome. I think if you look at NSX, there's a reason why VMware is just like growing money trees in their backyard right now with it.
because it solves a huge problem. And I think the future of that is not only IPv6, but I actually think it's going to be EVPN on hosts. And so taking that EVPN component, pushing it all the way down to the server, in which I now have, I mean, this is pretty close to what was talked about this morning, but I can put a VRF on the compute node, I can put each tenant within a VRF, and then I do VXLAN from compute node to compute node using BGP EVPN. So I think both of those components, so 100% agreement on IPv6, but I think that's only half the story. Look at this, right in order. This is beautiful.
Hey, Aditya from Arista. I have a quick question. So the solution of running VXLAN on the servers, that's kind of adding a lot of software complexity on the server, because now the server has to run the routing protocol and the VXLAN as well. Wouldn't it be better to push things to hypervisor?
So the question about pushing the complexity of the hypervisor, it kind of does that. So BGP sits on the side, and it's just advertising an endpoint. And the overhead of BGP is non-existent. I mean, it's like a ping, right? You're sending a hello every 1 second, maybe every 3 seconds. You're receiving only a default route, because I don't care about anything else. I just have to go to my top of rack. I'm advertising a single IP address. So the overhead of BGP is small. And then the hypervisor is controlling the VXLAN tunnel definition. So it's up to the hypervisor to take traffic from the VM into the vSwitch and place it into a VXLAN tunnel. That's the job of the hypervisor itself. Does that answer the question? I feel like I might have missed the mark a little bit.
Yeah, but the only thing is on the server, you have to also maintain the state for the routing protocols and the state for the VXLAN as well, right? So why maintain, that's just an additional state that you have to maintain on server. Adds up the complexity.
I'm not going to deny that it is an additional complexity, right? That was called out. But I think the piece here, though, is maintaining state for VXLAN is no different than maintaining state for VLAN. It's exactly the same. It's a soft state thing in which it's a forwarding entry, meaning that if you want to reach this destination, this is the rewrite on the packet. It's not state like a NAT table or a load balancer table. Right. So I think there's a little bit of additional complexity, but the largest OpenStack clouds that I've ever seen have all been doing VXLAN on servers.
Gotcha. Thank you.
You're welcome. In the middle.
Hi, Hugo Slabber, Demonware. Couple of questions, but skip the other if you want, if we're short on time. So the one was for if you're doing server-to-server VXLAN, I would assume that's generally more greenfield, because the challenge of integrating that VXLAN with an existing L2 environment, so that's more just isolated as opposed to integration, right? Yeah, so that is most of the deployments I see. You could still use a top-of-rack switch to do that termination. Yep. And so I terminate VXLAN on a switch, and then it just goes out to a trunk port or an access port to an L2 environment. I've seen customers do that. Yeah. But I think the reality is, like, OpenStack's not old enough for there to be brownfield OpenStack environments. And if you have a brownfield OpenStack environment, you probably want to burn it down and start over anyway, because you're like running whatever was the B release, I don't know, Bumblebee or Banana, I don't know, and it's all terrible and awful. So yes, but I don't think it's a common problem. Cool. And the last one, if there's no others, you were talking about the routed deployment down to onto the host. I think we had a discussion at some point on a Slack side of, well, how do we do that? How do we do server bootstrap in that environment if you're doing unnumbered v6 down to the box? My provisioning setup versus
This is a super astute question, and you and I can talk with whoever else in the hallway because it's a longer conversation. Go to the back, and then Andre, and then I think that's time. One more. All right, in the back, Andre, you and I will talk offline.
I get the last one. This is Carlos Vicente with Dyn. I just wanted to warn some people, especially new engineers doing designs for the first time, to question the definition of tenancy. If you're building a private cloud and you consider your customers as tenants, and actually they're all working with you, and they're, the database team and the web team and whatever, you don't need tenancies really. You don't need VLANs. There's nothing simpler than a single subnet per rack, and you can push your security down to the host level or the application level. So try not to over-engineer.
Yeah,
but good presentation. Thank you.
Thank you. I mean, appreciate it. Totally agree with that. The last thing I'll say is, I had a day of meetings with customers, And every single customer is like, yeah, so we run this multi-tenancy, except for the storage as a service. I'm like, okay, well, here's some solutions. And I go to the next customer and they're like, so we have multi-tenancy, except for this Hadoop as a service. I'm like, okay, here's some options. And I go to the next customer and they're like, so we have many tenants, except for this security as a service. And really, as we started to dig in, it was exactly what the gentleman said, which is like they didn't really have tenancy. They had built in a bunch of artificial trenches that made things extremely difficult. And if they just routed it all, we wouldn't have had to jump through a bunch of flaming design hoops. So I think it's a really good point. So I'm out of time, so thank you all very much.